Hello again for the Posh Lavish Digs of Mill City Roasters. I'm Steve Green. I'm joined by the illustrious...
I'm Lauren Lathrop.
Oh, that's
hello.
right. And Patty, the shop dog.
We're here in our shipping and receiving warehouse today, and we're taking a rare opportunity to take a look at our very large Mill City 60K roaster. It is not usual to have a machine of this size, or really any machine in stock for long enough to photograph it, let alone video it. And so we wanted to, what was the phrase you used?
Carpe the jugulum.
We wanted to seize the opportunity.
You really like that.
I do, I like it. Wanted to seize the opportunity to take a tour of this roaster and have a conversation about all of the engineering and design that went into making a machine of this scale operate at the same level as some of our smaller roasters. What's cool about it, and we'll talk about the control panel and some of the other features, but you know, it really mimics some of our smaller roasters. Mm-hmm. So it's true that if you're roasting on a 1K, a 2K, a 3K, you'll still feel quite at home here on the control panel for the 60.
Yeah, the way we make it work, mechanically, all of our roasters have very similar construction. It's just very much scaled up on the 60K. So, just starting at the front of the machine, this plate is a little better than 5/8 inch solid 304 stainless. That plate alone probably weighs 800 pounds.
Wow.
Yeah, for real.
That's very big.
This drum door is wire EDM'd out of that plate for a tighter fit.
Yeah, so it's like a glove.
Which is a very, you know, the reason that people don't build like this is extremely expensive. It's just a challenge moving that huge plate of material into position to work it.
Yeah. Much
less finish it and bolt it to a machine. This drum, when we go back to the roaster, it's got an 8mm inner wall. The requirement to bend 430 stainless steel into that shape is something like a machine that's capable of bending a 3/4 inch mild steel plate. The machinery is literally, you know, double or triple the expense. So that's kind of where it starts. The whole thing starts with construction. The reason we do that is a bigger machine has more stability, better thermal mass, and then we can add more heat.
Right.
Because we need to move that batch size along at a similar rate to the smaller machines.
Yeah.
The BTU to bean mass ratio.
Yeah, 60 kilograms of coffee is a lot of coffee.
It's an entire bag.
That's true.
Woohoo! So let's go to the side. Let's look at the chassis for a minute.
Cool. I'm gonna open this up.
Wow.
Wow.
Okay, so a little crazy. This entire machine is one gigantic solid weldment. There are no fasteners in this whatsoever. It is welded solid. And if we come over here, this is something like 92 millimeters thick.
Yeah.
Now it's not solid steel. What this is this chassis is solid plate steel. There's braces called gussets in between the walls, so it's very dimensionally stable. And then we insulate the entire thing. The steel in this roaster absorbs something like 0.19 BTUs per pound per degree Fahrenheit. What that means is the chassis of this machine can provide 70,000 BTUs at the beginning of the roast. And the reason that's important is because, yeah, I can do that with a burner, no sweat, but my inlet temperature climbs so high that I'm in the range, easily in the range of convective heat defect.
Yeah.
So construction of the drum, solid double-walled plate, very heavy, very responsive. What it allows us to do is generate a tremendous amount of heat and bring that into the coffee seed without defect.
Well, I want to talk about the control panel because it will be pretty familiar to folks who are on any digital control panel Mill City roaster, where all of our roaster variables and our inputs are controlled with these, what we call arcade buttons. So we've got our gas pressure, our fan speed, and our drum speed, all digital controls, which means that our data logging system, RoastPATH, is going to harvest that information for greater efficiency in reproducing production roasts.
Sure. So the digital control system is 15 sensors and readouts.
Yes.
Every single thing an operator does during the course of the roast is recorded, it's assigned a number, and it's recorded then in RoastPATH.
Yep.
RoastPATH hoovers up all that information. And we can talk about RoastPATH a little later. The reason I specifically did not do a touchscreen display, everybody thinks touchscreen displays are super cool. Well, if I'm, if all of a sudden I'm in my roast profile and I'm a little off, I don't want to have to go down 2 menus or 2 additional screens to make a change to my airflow.
Yeah.
I want to be able to tap
Right
my
here.
airflow,
Yeah.
right?
That's a button.
And one of the things with the digital control system that's very interesting is we designed this entire thing. I mean, like, we programmed the buttons to mimic the responsiveness of the manual machine.
Yep.
That is not, usually what you do is you create this thing in some program, right? And you're like, there's a default setting for the button response time. It's X milliseconds. And everybody just uses the default because it's like drag and drop. You just put it into place graphically and it works. Well, when we did that, we'd press the button and we'd sit there and twiddle our thumbs for 30 or 40 seconds waiting for the gas valve to move. That was shot. So what we had to do is, if we were to actually look at this, the motor that controls the gas valve on here, we went through something like almost 20 different motors trying to find the exact balance of torque and speed. So when we hit the button, it would just move into position instead of hitting the button and waiting, or hitting the button and have it overshoot.
Yeah.
And then hunt for the gas setting. It's a little kooky and it's a little obsessive, but I have literally spent something like 10,000 hours
Well, and you
trying
need
to figure
that.
this out.
You need that level of accuracy with roasting, especially like large batch roasting, because especially at the end of your profile, every degree, every 5 seconds is going to make a huge difference in the cup.
Yeah, we custom designed the firmware for all this stuff.
Yeah.
We actually did that here. Because coffee's God's gift to the obsessive compulsive, and I qualify.
That's true.
So, under the hood, and one of the things you're going to notice about the 60K and really all of our roasters, but especially the bigger production machines, everything is behind a door. The reason we do that is if something goes kittywampus here and you got to call tech support, they're going to get on a call and you're going to have your camera here and they're going to be looking at your controls. It needs to be accessible, it needs to be well lit, it needs to be out in the open. And in the worst case scenario, where you have to come in and start tugging on wires to find the loose one, because that's nearly always what it is, now you can get at it without contorting yourself.
Yeah. And you were telling me earlier that this whole thing is on hinges. Mm-hmm. So this entire control panel will actually swing out so that you have access to 2 massive cooling tray fans underneath. They're very big.
So the cooling tray fans are
Yeah.
about 2.5 feet across.
Yeah.
And they're high pressure centrifugal blowers, this is an interesting thing with so if you get hired by somebody to design a new model roaster,
Sure.
typically you're a
I wouldn't, but someone might. Yeah.
Typically you're a mechanical engineer, you're about 60 months out of school because you're cheap, right?
Right.
And what you do is, because you're smart, you look in the catalog and you find the blower fan that produces the greatest number of CFM for the least cost. That's what you do.
Sure.
Smart, right? So what they do is they buy these fractional horsepower squirrel cage blowers. They're like the blowers in your furnace at home.
Sure.
And they think, wow, this is great. I can get 500 CFM for $300, right? Well, the problem is that style blower, the minute the airflow is restricted, the CFM drops to 10.
Right.
Which is the reason that a lot of other manufacturers, don't tell them I said this. Of course, they'll all be watching this now saying, oh, that's not true. That's not the way it works. Yeah, that's exactly the way it works. Shockingly, when you put coffee in the cooling tray and cover all the holes,
Restricts
guess
airflow.
what happens?
Yeah, it slows everything down.
No airflow. It's super stupid. I mean, it really is kind of ridiculous. Don't tell them I said so. So we use almost more like a vacuum blower. It really is. It's the same style blower as a vacuum. And it overcomes that restriction and it pulls that huge volume of air. On this machine, we don't use just one, we use two.
Yeah.
Because what we're trying to do is cool an entire 60 kilogram batch down from second crack to something like bagging temperature within 4 minutes.
Yeah.
That limits carryover cooking. And a lot of times the big machines will present very depleted acidity, and that's because of the carryover cooking in the cooling tray.
Yeah, with those longer cooling times, you get that that flatness and that sort of kind of like roast, like smokiness.
Yeah, it's
sometimes in
coffee.
the Yeah.
I mean, look, I'm not saying it's bad, and if you like that, that's cool.
Yeah.
I don't have a problem with that. But I just didn't think, I think you should plan, that should be your intent. That shouldn't be the thing that you get stuck with in the machine.
Yeah, we see it a lot with students in class with our 6K or even the 3K. You know, people can't believe how quickly the coffee is cooled down.
Yeah.
And it's nice to be able to kind of count on that same cooling standard for the large machines too.
Yeah, all of the 3 kilogram up all have that same exact blower.
Yeah.
They don't make them small enough for the small machines, so we just size up those. We use a slightly different, actually if you look at it, it's an anti-fouling motor, so it can't get clogged up in that small space. Because what happens is those inexpensive motors often get clogged up with, you've seen it before. We've seen pictures from people.
Yeah.
They're like, hey, do you have a fan for my roaster? Well, no, we don't, because your roaster sucks. Let's button this up and wander over to the drum.
Cool. You know, everyone thinks a drum is simple,
I know.
but it's really not.
Well, you know, it's a thing where people have a familiarity with the thing and they mistake that for expertise.
Sure.
So
Well, and in class we simplify it too. We say a drum is a barrel turned on its side.
it's true, and at its grossest level, that's exactly what it is. But if you are going to roast at capacity and beyond without heat defect, let's talk about the drum. The first thing, it's got to contain the coffee. But that's not quite as simple as you think, because remember that big, huge, heavy faceplate? That mates up with the face of this drum at a specific distance. And typically what happens is we start from a cold roaster and the drum expands. There's expansion of the drum. So we would start at maybe 3.5 millimeter drum gap, which is big enough to have seed loss between the faceplate and the drum.
Dropping down into the burner tray.
Right. When we bring it up to full preheat, we close that by maybe as much as 2.5 millimeter. Mm-hmm. It's kind of interesting. So the second thing that the drum has to do is it has to use all the heat in the roaster, all the latent heat energy in the system, the latent heat energy in the drum itself, and the thermal energy off the burners, and it's got to pass that somehow conductively and convectively to the seed. The other thing that the drum has to do is it has to provide even roasting and good mixing,
Yes.
right?
Yeah.
So let's take a step back and let's talk first about how we manage drum gap during the roast. So this is interesting. This is a spare 60K drum, and the reason that this is a spare 60K drum is because we designed this drum for the 30K and we scaled it up for the 60. And the reason we did that is we wanted to make it stronger. So instead of 4 cross braces, we went to 5, and we made these round. And the reason we made these round was because we changed the geometry to eliminate seed retention. The other thing that the drum has to do is all of the seeds that go into the drum have to come out of the drum.
Right. So you're not fishing out all those
Burnt
little
seeds.
overburnt. Exactly.
And people don't know, but that's a place where a lot of chaff fires happen. Because the seeds get caught and they absorb so much heat they turn into embers.
Right.
And when they lose enough mass, they get sucked through the airflow and into the chaff collector.
And then they light the chaff on fire.
Yeah. So we created a very, very large gap back here, so it's impossible for seeds to get caught between the bracing and the rear perf. And then we did very aggressive vanes to get higher loft in this drum at lower drum speeds to optimize the conductive convective ratio. Now you have control over that relative to batch size with variable drum speed.
Right.
We do that.
Yeah.
Which is the second thing that, well, maybe that's the first thing we do with these drums. We build these so heavy because it is possible to accidentally preheat your roaster with the drum rotation at 0. Mm-hmm. This drum is built heavily enough. This is 8 millimeter inner wall, 3 millimeter gap, 4 millimeter outer wall. This drum is heavy, and it's welded solid. This is a solid weldment. There's no fasteners, there's no rivets. There's hundreds of welds in here holding this thing together. Kind of interesting.
Yeah.
These holes, incidentally, are designed to restrict
Expansion?
heat expansion.
Yeah.
This is a novel idea that we stumbled onto, and we implemented that in several of the larger roasters. So, very strong, very heavy, and exactly what we were talking about. This is 430 stainless. 430 stainless mimics cast iron. It's a very high iron content stainless. It releases heat the same as mild steel, which is useful because cast iron releases heat very rapidly, and it makes it more likely to scorch or tip the coffee seed.
Sure.
But the outer wall is designed to diffuse heat evenly throughout the inner wall.
And then when we go back to the front of the roaster, we'll see that spanner adjustment, which is how we can adjust that drum gap.
Yeah, that was a whole nother saga we'll talk about a little bit. Let's go to the rear. I want to show you something really interesting.
Cool.
Okay. For 20 points, somebody tell me what the hell these are.
These are called louvers,
Okay.
not fins.
So this is a little kooky. I did a couple things back here that are I'm sort of proud of because they work so well. So number one, we put this bracing on the back of the drum to keep this perf from warping. This perf is obviously entirely perforated.
Sure.
So it can distort. It wouldn't matter, but I eliminated that with these very, very heavy braces on the back of the drum. It's kind of neat. This is actually, the drum in that roaster is shaftless. It's yet another version of this, absent the shaft, to try to eliminate the heat expansion in the shaft.
So it just got those braces inside. Yeah.
Yeah. These had to be heavy enough to support the entire structure of the drum without the inner shaft. So what these louvers do is these scoop up heated air, and they accelerate it, they restrict it at the back and accelerate it into the drum. What this does is it creates a neutral airflow environment. So rather than having to run my fan speed so high that I'm increasing my drum pressure to the point where maybe I'm sucking very light seeds up at a higher drum speed,
Yeah.
I can create a neutral airflow where my fan speed is more precise, or my airflow is more precise.
So then you can really control that convective heat transfer.
Yeah, and it also helps to minimize that drum expansion, because drum expansion happens when heat is localized in one portion of the drum. Airflow transmits that heat evenly, or what's the word I'm looking for? Distributes the heat evenly through the system. So localized heat is inefficient and uncontrollable. Diffused heat is a useful tool for roasting.
Yeah.
It's a big deal. People, again, until you actually start working on this stuff, you don't really understand how important that is.
Are these louvers only on the 60K?
Yeah, I did install them on the 20K. It didn't have much effect. It just wasn't a thing. And I think part of it was just the size of the louver itself, just
Yeah.
the volume of air was less because the louvers were so much smaller.
Interesting.
We're still experimenting on the 30K. We haven't done that yet on the 30K. It's something I'm playing around with to see if it makes a difference. But here's the thing. The 30K is running so sweet right now. I'm kind of afraid to touch it.
Don't fix it if it's not broken.
Don't fix it if it's not broken.
Cool. What do we want to look at next?
Let's go back to the roaster and let's talk a little bit about RoastPATH automation
Okay.
and the chaff collector and the loader.
Cool. So we wanted to talk about these sensors and RoastPATH automation.
Sensors galore. Okay, so look, here's the thing. In engineering, if it matters, you measure it. The trick is to know what matters.
Right.
There's all kinds of stuff you can measure. We're measuring the stuff that really matters.
Right.
And let me tell you how that works. So RoastPATH, again, has 15 sensors and readouts. Or, I'm sorry, the digital control system has 15 sensors and readouts.
Which RoastPATH reads.
RoastPATH hoovers up all that data. So we start with drum temperature, which is a centerline probe. It's marginally farther removed from the drum gap.
And that's also the temperature that we'll see on the PID display on the control panel.
Yeah. We very often use drum temp as charge temp.
Right.
Because it's the best reading of latent heat energy in the system. Bean temperature, which is a probe that's simply in the bean mass during the roasting process, right? Environmental temperature is the temperature of the drum. It's an air temperature of the drum where these seeds are not.
Right.
So, and then lastly, there is another probe on the rear of the drum where the hottest air comes in.
That incoming temperature.
Yeah,
Okay.
and you can monitor that for two reasons. The first one, there's always a differential between the incoming air temp and the environmental temp. Whatever that differential is represents the amount of energy that's gone into your seed and the amount of energy that's gone up your stack.
Sure.
It's kind of interesting. You can also start to identify inlet temperatures that put you on the edge of convective heat defect.
Right.
So remember, 60 kilogram of coffee, 130 pounds, roughly,
34.
right?
Yeah.
You're talking about $500, $600, $700 at risk for every batch. You really want to know exactly what's going on in the system
Yeah.
at every second. I build the roasters the way that it's my decision. It's the way that it's what I'm interested in. If you want to roast off the analog temperature gauge the way that we did 30 years ago, that's perfectly fine, and I don't think you're wrong.
Sure.
I'm just giving you options.
Well, it's all a reference point, right? So
Yeah.
as long as you're using the same reference point from batch to batch, you can still be consistent.
For sure. Drum pressure is a feedback loop for airflow. So one of the things is you can't see airflow. All you can see is what it does.
Right.
Right?
Yeah.
So what drum pressure is on the control panel, the drums or the fan speed hertz. So it's 0 to 60.
And that's just energy that's going to the fan.
That's the number of times the electricity turns on and off per second.
Right.
Right?
So
Hertz.
you're getting that number and it's showing what you're asking the fan to do.
Right.
But that drum pressure gauge is telling you what's actually happening.
It's a feedback mechanism for actual airflow. So what's going to happen is you will calibrate. You'll say, okay, my low airflow is 13.6 hertz.
Yep.
If my fan is crowded up and I've lost efficiency in my fan, now all of a sudden 13.6 may not be moving much airflow at all.
Right.
So what the drum pressure gauge does is it allows me to recognize, what's going on in the atmosphere, what's going on with my venting, what's going on with my fan, what's going on with my drum speed or batch size. Because as that coffee is moved through that drum, larger batch size slows down more airflow. So we want to keep airflow. The reason that we do that is because airflow is your heat transfer is 70% convective.
Convective heat. Right.
Now you'd say, oh, well, gee, why do we want any conductive heat? Well, the reason you want conductive heat is because conductive heat is where your machine control lives. The differential between your seed temp and the surface temp of the drum, if you can get that into equilibrium point at your desired rate of rise, you're trying to maintain balance in that system, so any input change that you make registers as a change in your coffee. That's where control lives. That's what we're doing. I know it sounds a little kooky. All you got to do is run the roaster. What you're going to find out, some of you've never roasted before, roasting is a physical skill, exactly the same as riding a surfboard. It's exactly the same thing. You are anticipating changes in your equilibrium of the roast, exactly the same way as if you were trying to ride a wave.
I did want to talk about the cooling tray while we're up here.
Okay.
So the cooling tray is massive and it has a huge cover on it as well. One of the things that we do with all of our roasters is size up the cooling tray so that it can accommodate 3 full batches of coffee. And we do that for blending.
Yeah.
And, well, we already talked about cooling times.
And it's not just blends.
Yeah.
Like if you're in production roasting, right? You know, if you've got a spec, you've got a roast spec. Well, if you're a little outside your roast spec, 100% for sure what you're going to do, you're going to blend all of your batches so you've got a homogeneous thing.
Sure. And then we get a consistent product on the retail shelves.
Yeah.
Cool.
It isn't, there's worse things.
Yeah. Let's take a look at the Chaff Collector.
Chaff Collector.
This is a huge Chaff Collector.
A huge Chaff Collector. But there's a lot more here than meets the eye.
Okay.
So the first thing is, we include the Chaff Collector with every roaster.
Comes with it.
Crazy. Second thing is, this actually comes apart.
Wow. Why?
I know, it's super weird, right? If we could reach up here, if we tip this over, if we disconnect it and tip it over, this entire top comes apart so that you can get at the inside of the Chaff Collector and really clean it, you know, for your quarterly maintenance.
Yeah. What if I don't want to take the whole top off of it?
Doors.
Cool.
So what happens inside this Chaff Collector is there's a very large tube that comes down. It's perforated.
Yep.
And this high pressure air comes in to the top, and as it expands, it creates a low pressure pocket in the bottom of the Chaff Collector. Now, inside this thing, there's actually a huge cone that very much dramatically increases the efficiency of chaff collection, so you're not blowing chaff all over the neighborhood.
Sure.
Score! But for my, you know, maybe my daily, weekly maintenance, I open these doors and I can get in there and I can brush all that stuff out and vacuum it.
Yeah.
And I can open this even while the roaster's running. I can open it mid-batch and suck out the chaff because the pressure is so low on the bottom of this. It's actually pretty neat. The other thing that's interesting is we have water quench on these roasters.
Right.
We haven't talked much about safety yet, but safety is over temp limit. So when the roaster hits a certain point, it shuts itself, it cuts the burners out,
Yep.
right? The construction of the machine renders them pretty much impervious to drum fires. If you lose power mid-roast, the transformer down the street blows up, which actually happened to me once. Everything stops. There's no airflow. There's no burners. There's no. And coffee just sits on in the drum, and it will start on fire.
Yeah.
Don't worry about it. It's going to get smoky, but it ain't going to hurt anything. Over here, I don't know if we can see this, but there's a huge hand crank, so that in the event of a power loss, I can turn the drum manually, and to keep the coffee from burning. Right?
And to get it out of the drum if we want it.
And eventually you get it out when it's cool.
Yeah.
So that's neat. We have never lost a roaster. We've never seen a warped drum. Never.
Yeah.
We've never had anybody be out of business for more than about 8 hours. The 8 hours, 6.5, 7 hours it takes sometime to clean everything and rerun their seasoning roast, but they're back up in production the next day.
Yeah.
Back of the Chaff Collector, there's a water quench. There's an optional mist cooling system that an operator can adjust. What that does is it mists the bottom of the Chaff Collector. If you set it up exactly right, it decreases the temperature in the bottom of the Chaff Collector by about 100 degrees, and it quenches any embers that come through. That's super cool. It's an optional thing. If you want to do it, let us know. Standard on the machine is a full-blown quench. So if there's ever a fire in this, all the operators got to come back here and hit this valve, open this valve, and it'll quench the system. We have the same system on the front of the roaster.
Yeah.
So in the case of a
quench.
drum fire,
Yep.
you know, you lose power, you give it a shot of water. It doesn't take much water.
Well, yeah.
We did have a customer one time, the fire department pumped 200 gallons of water into his drum, and we had him up and running the next day.
Probably more than they needed.
Yeah.
Yeah.
So kind of fun.
So I think the last thing we want to take a look at on this machine is the loader.
Loader.
Let's go.
Let's do it. high performance thing. We actually use the same fan as we use for the cooling tray.
Cool.
So I can bring 60 kilogram of coffee into this roaster in about 30 or 40 seconds. That's super fast. Most of them are like 3 or 4 minutes. The other thing is, you'll see a lot of manufacturers, they'll put the motor way up on top of here to eliminate this piping, which is great. There's 2 problems with that. The first one is you got to get up there to do maintenance on that. That super sucks.
Yeah.
The second thing is they don't have a filtration system. So they blow green coffee dust all over their shop from 14 feet up or 12 feet up or whatever it is.
So this is the green coffee filter.
Yeah.
And it's super airtight. And I'm guessing this is probably replaceable.
Yeah.
Yeah.
They're on the shelf in the warehouse.
Cool. So keeps the space clean and keeps people's lungs happy.
So this is a weighing hopper. This has been a challenge for us, and I'm still working on this, trying to get it right. Where this should tear out, and we should be able to measure to within maybe a pound of batch size. Wow. It's kind of handy.
So I think that's what we wanted to cover on the loader. So the last thing we want to talk about is RoastPATH automation.
Well, let's go back to the machine for a second. So we build this enormously sophisticated thing, and it really was designed to mimic manual control.
Right.
But RoastPATH has grown now. Currently, we're at almost 700 members in the beta group, and those guys have logged coming up on 90,000 roasts.
Wow.
Which is pretty interesting. So currently, today, the current release of RoastPATH is we gather all this data, and it's a software as a service product. Everything lives in the cloud. Each roast profile is recorded from start to finish. Everything an operator does is recorded. And you can use that data to replicate roast profiles. You can superimpose, you can open up the notebook. It's a timestamp thing. It's pretty sophisticated. I mean, we really put a lot of design effort into it. But that is currently all one-way communication.
Right.
So the roaster is transmitting that to RoastPATH. But the technology that we use has the capability of taking control of the roaster, which means that in RoastPATH, in this upcoming release, there will be an option for people to do kind of a roast replay. Mm-hmm. So we take all that data, the machine sets itself to preheat and prompts the operator to charge the drum at a point and prompts the operator to discharge the drum at a point. Now we do have, because they're so high up in the air, obviously, we've got a pneumatic charge and pneumatic discharge. We do still have the capability to bring that into RoastPATH, but I gotta tell you, I feel like people use automated roasters too often for unattended operation. Yeah. And I honestly think that's really dangerous. Yeah. I just think it's bad. I think coffee quality suffers. And I think it's dangerous. Things go off the rails pretty quick. You need somebody to step in. So even with all the safety and everything we built in, you don't know what's going to happen. Again, power goes on a roaster, operator's got to be there right now. Yeah. So we're still playing around with that. That's still a work in process.
Yeah, and we talk about that at length with students too, is if they get to the point where they're doing a roast replay and using a high level of automation, we're still going to always really recommend that someone is there to observe and keep an eye on things.
Well, it's a big expensive machine, and there's a lot of money at risk in that drum. Yeah. And here's the other thing. I talked to a guy the other day, and this is kind of interesting. They were roasting on a SF6, and he called us for a 20 kilogram roaster, and he was super worried about labor. Mm-hmm. He was like, oh my God, we need automation. We got to take all the labor we can out of this. And I'm like, dude, have you done the math? Like that machine, the productive capacity of that machine is something like $800 an hour. Yeah. Are you telling me you can't afford to pay somebody $17 to run the roaster? I mean, he's like, oh, I never thought of that. Hand to God, this is a true story. It's, sometimes we get kind of locked in our paradigm. We get locked in our thinking. What I am trying to do with this and all of our roasters is create a better tool for people to use to get better coffee to build their business and their brand, right? That's kind of the gospel that we preach a little bit. And, you know, I'm constantly kind of searching, I'm constantly re-examining assumptions that, you know, are kind of like received wisdom, like, oh, mild steel is so good. Yeah, no, it's not, it sucks. Or, you know, oh, you know, you need this type of burner, or you need this cast iron, or whatever it is. Yeah, no, you really don't. Now, you know, if all you know is what you know, you're kind of more of a technician, a little less of an engineer. You're a little more of an engineer and a little less of a roaster. You know, it's easy to start thinking like you've got not invented here syndrome. You know, you've got places you don't go or things you never consider. I think coffee's bigger than that.
Yeah.
I think it's more important than that.
Well, the good news is we're engineers and we're roasters. And all of this thinking and theory goes into the design and build of these machines. And I think that when people get a chance to use them and operate them, I think that a lot of your intentionality and thought process behind them will come through in the cup.
Seems to.
That's the hope.
Seems to.
Cool.
I'm proud of our people.
Yeah.
Proud of you.
Thank you. So this has been a very in-depth overview of our 60K. If you've got questions, let us know about them. We're always happy to talk about this roaster and about all our roasters.
Yeah.
Until next time, thanks for watching.
Thank you, and good night.